So this is a question given in GATE 2020-21 in which you have given a continuous time signal x of t, and you need to find out the Fourier transform of x of t and find out the maximum magnitude of x of omega. The NPTEL reference for this question you can find in Principle of Signal and System by Professor Aditya Jagannathan. The useful data for this question is that if you remember the formula of Fourier transform of triangular function, then this question becomes very easy. So the Fourier transform of a triangular function, which is defined from minus t to t, which has amplitude of a, then the Fourier transform of this triangular function will be, if it is x of t, then Fourier transform x of omega will be a times t sampling function square of omega t by 2, where sampling function defined by sampling of x equal to sin x by x. So if you have a triangular function which is defined from minus 1 to 1 or amplitude is 1, then you can write Fourier transform. If a equal to 1 and t equal to 1, then you can write Fourier transform as x of omega is equals to sampling square of omega by 2. So you have given in that question that x of t is equals to 0 when mod of t is greater than 1, which implies that if t is greater than 1 and t is less than minus 1, and x of t is equals to 1 minus mod of t when mod of t is less than 1, which is minus 1 to t 1. So when you plot this x of t, then from minus 1 to infinity the function value is 0, and from minus 1 to 0 this is the 1 plus t, because mod of t will be your minus t and 1 plus t. The graph for 1 plus t will be a ramping function with positive slope, and from 0 to 1 it is 1 minus t. So you can plot this x of t as a triangular function which has amplitude of 1. So as we discussed, the Fourier transform of this signal is sampling function square omega by 2 when a equal to 1 and t equal to 1 in a generalized triangular function. So when you plot this sampling function, then it will be sinc function, and this is at omega equal to 0, and this is your omega axis, and this is your x of omega. So the maximum magnitude of x of omega is 1. So answer for this question will be 1. So this is the one way to solve this question when you remember the Fourier transform of triangular pulse. The another way to solve this question is that by regular method. So you have x of omega for a given x of t will be given by minus infinity to infinity x of t e to the power minus j omega t dt. So when you put x of t in this integral, then you will get, as x of t is defined from minus 1 to 1, then from minus 1 to 0 this function will take value as 1 plus t e to the power minus j omega t dt plus 0 to 1. Now this x of t becomes 1 minus t, because mod of t will be t between 0 to 1. So it's become 1 minus t e to the power minus j omega t dt. So after solving this equation, you will get x of omega, and which is nothing but x of omega you will get as sampling square of omega by 2. So let's solve this equation by integration by parts. So you can write this first integral as 1 plus t e to the power minus j omega t divided by minus j omega, integration from minus 1 to 0 minus integration of, this limit becomes minus 1 to 0, and e to the power minus j omega t divided by minus j omega dt. This is integration by parts. I am solving this integration by parts, where I have taken this one as u and this one as v. So the second integral becomes 1 minus t e to the power minus j omega t divided by minus j omega, integration from 0 to 1 minus integration of 0 to 1 and minus 1 e to the power minus j omega t divided by minus j omega dt. Further you can solve these integrals, and you will get 1 plus t e to the power minus j omega t divided by minus j omega, integration from minus 1 to 0 minus e to the power minus j omega t divided by minus j omega square minus 1 to 0 plus 1 minus t e to the power minus j omega t divided by minus j omega, integration from 0 to 1 plus e to the power minus j omega t divided by minus j omega square 0 to 1. When you put these limits in this integral, you will get 1 minus 1 by omega square plus e to the power plus j omega e to the power plus j omega divided by omega square minus 1 plus e to the power minus j omega divided by minus omega square plus 1 by omega square. So 1 and 1 get cancelled out, and you will get 2 by omega square minus 1 by omega square e to the power plus j omega plus e to the power minus j omega by 2 multiplied by 2. I am multiplying by 2 and dividing by 2 to make it cosine. So you will get 2 by omega square 1 minus cos of omega, and you can write this one as 2 by omega square 2 times sine square omega by 2, and you can write this one as sine of omega by 2 divided by omega by 2 whole square, which is your sampling square of omega by 2, and this is your graph of sampling square omega by 2. which has maximum magnitude of 1. So the correct answer for this question is 1.